Every enterprise is racing to adopt AI, and two things are quietly spreading across their networks. MCP servers, the tools that agents connect to, get stood up by different teams with no review. And AI agents themselves are running in production, calling large language model providers like OpenAI and Anthropic. Nobody has a complete inventory of either one. This organization is a clean example. No agents registered, no MCP servers registered. Let's find out what's actually running. Here's the environment behind the scenes: a handful of AI agents and a handful of MCP servers running on private subnets with internal IPs only, the same way they would run inside a customer's own network. ArmorIQ is about to discover all of them without touching a single one directly. Let's start with agents. Agents don't listen on a port you can scan. They're like clients that reach out to the internet. So discovery works differently here. The only thing a user provides is the internal network range to look at. Underneath, we read the cloud provider's own network telemetry, VPC flow logs, and cloud DNS logs to see which workloads are calling large language model APIs. I want to be precise about what this is. This is metadata only. We are not doing deep packet inspection, and we are not reading the content of any request. We're also not just detecting any traffic to OpenAI or Anthropic. Distinguishing a person chatting with an AI assistant from an autonomous agent making tool calls is a real problem. And that pattern matching is the next phase of this work. What you'll see today is the discovery layer underneath it. I'll give it the internal range and a look back window and scan. In a few seconds, it found the agents on this network by their egress to large language model providers. For each one, it shows which provider it's calling, how many calls, and how much data has moved. Every one of these is currently unregistered, a shadow agent that nobody in the organization knows is running. One click registers it into the inventory. This is our payments agent, and it's now a governed agent that ArmorIQ knows about. Now, the MCP side. Unlike agents, MCP servers do listen on the network. So here we can sweep the subnet directly. The user gives us the internal range the same way you'd point network mapping tools like Nmap at an internal network, except purpose built for MCP. We also point it at a small scanner that runs inside that same private network. Since this range isn't reachable from the outside, I'll fill in the range and the scanner address and scan. It swept the subnet and found the MCP servers running on it. For each one, it pulled back the tools it exposes and scored it for risk. This one right here is our payments MCP server. And these are the real tools it exposes for working with invoices, transactions, and payments. One click and the payments MCP server is registered too. Now, both halves of this workflow, the agent and the MCP server it talks to, are inside ArmorIQ's inventory. Here's where it comes together. This is the payments agent's own interface built with the ArmorIQ SDK. I'll ask it a real question that requires it to use a tool. Every tool call this agent makes goes through ArmorIQ for enforcement. And if I switch over to the AIQ graph and turn on live, you can see it happen in real time. This is the agent we just discovered invoking a tool call on the MCP server we just discovered. This is a live governed connection between two things that 5 minutes ago we didn't even know existed. That's the full loop. Point ArmorIQ at a network, and it finds the agents and the MCP servers running on it, what they expose, which large language models they talk to, and how risky they are. Bring the ones you care about under governance with one click, and watch every tool call between them live in the graph. Everything you just saw ran in our own cloud. The exact same flow runs inside a customer's own VPC.